Next example. So for this circuit, we are going to solve RT, total resistance, and branch circuit currents. RT, branch currents, what else? And power in resistor 6. So P6. First, we must label your circuit and the direction of your current. So we have here, this is R1, which has a current of I1, but this branch is your total current. So your IT is equal to your I1. So total current is equal to your I1. And then this current will split into two. This branch R2 and the rest of this branch. So you have a direction of current downward here. And you will label this one, since this is R2, we'll call it I2. R3, I3. Again, this I3 will split into two branches. We have your I4, I5, and I6. So as you can see, R5 and R6 are connected in series. Therefore, I5 is equal to I6. So solving for the total resistance, we will examine your circuit, identify the parallel and series, so that we will come up with the total resistance. So you will begin at the back of the circuit. So this is the front. In your source, we'll begin to examine at the back to front. So R5 and R6 are in series. So R5 6 is equal to R5 plus R6. And then after the combination of these two, as you can see, R5 6 is in parallel with R4. So R4 5 6 is equal to R4 in parallel with R5 and 6. And then the combination of R4, R5, and R6, you will have one resistor, and then you will they are connected in series with R3. So you have R3, 4, 5, 6, R3 plus R4, 5, and 6. Okay, nalpaste dito yan yung R10. The combinations of R3, 4, 5, and 6 is connected to R2 in parallel. So R2, 3, 4, 5, 6 is R2 in parallel with R3, 4, 5, and 6. Okay. Last one, the R1. And now, that is your RT. So RT is equal to R1, 2, 3, 4, 5, and 6. So the combination of R2, 3, 4, 5, and 6 is connected in series with R1. So R1 plus R2 3, 4, 5, and 6. So we will solve this one by one. Okay. R56 is 1 kilo ohm plus 6 kilo ohm. So that is 7 kilo ohm. And R4 is 7 kilo ohm times 7 divided by 7 plus 7. So that is equal to 3.5 kilo ohm. Next, R3, 4, 5, 6, it's just sum because they are in series. So R3 is 2 kilo ohm. So 2 kilo ohm plus 3.5K is equal to 5.5 kilo ohm. 2, 3, 4, 5, 6. 2 is 8 kilo ohm. 8K times 5.5K divided by 8K plus 5.5K. So, 3.259 kilo ohm. Next, last one, we have the sum 3 kilo ohm plus 3.259 kilo ohm. So that is equal to 6.259 kilo ohm. Okay. Solving now your total current is equal to total voltage divided by total resistance. So our source voltage is equal to 111 volts divided by 6.259K. So 0.018 amperes. Ito yung nakakalito na, yung branch currents. So, paano natin masosolve yung I2? So, solving for I2. We will redraw the circuit. Like this. So, this is your R1 total current. This is your R2. And this resistor will be the combinations of R3, 4, 5, and 6. R3, 4, 5, and 6. So this is the direction of your I2 and I3, 4, 5, and 6. So dito sa IT, consider natin yung in terms of milliampere. Kasi renound off ko to kanina. So IT is equal to 17.73 milliampere. Okay, so solving for I2 using CDT. So CDT, I2 is equal to total current. This total current is the supplying current at this node. Okay? Multiplied by the total resistance, which is not this one. Han nga dito eh. The total resistance here is the parallel combination of these two parallel resistors. So the two parallel resistors R2 and R3, 4, 5, 6 is already calculated. So this is R2, 3, 4, 5, and 6 divided by the resistor R2. So IT is equal to 17.73 times 10 raised to negative 3 multiplied by R2, 3, 4, 5, 6, which is equal to this one, R2, 3, 4, 5, 6, 3.259 kilo ohm divided by R2, which is equal to 8 kilo ohm. This is 8. So I2 is equal to 7.222 milliampere. Next is I3. So, paano natin isosolve si I3? Balik tayo sa circuit. So, this is our node. Okay, nasolve na natin yung IT and I2. So, using KCL, or KCL, Kirchhoff's current law, we can solve your I3. Okay, at this node, let's say this is node 1, and this is node 2. So, using KCL, current entering is equal to current leaving. So, current entering at this node is IT. Current leaving are I2 and I3. So, dito, using KCL at node 1, IT is equal to I2 plus I3. So, solving now for I3, IT minus I2. So, that is equal to 17.73 milliampere minus 7.222 milliampere. So, that is equal to 10.507 milliampere. Okay. Now, how about I4, 5, and 6? Ganun din yung ginawa natin dito. So, examining your circuit again. we need to solve I4, I5, and I6. So using CDT, okay, we will redraw your circuit para mas maintindihan. So, i-copy ko na lang dito sa baba. Yes. So, I4 using CDT. Redraw muna natin. So, this is your R1, R2, R3, and this resistor will be the R4, and this one is R5 and 6, since they are in series. R1, R2, R3, R4, and R4, 5, 6. So, kailangan natin yung I4. So, I4 is equal to what current supplying I4 and R5, 6. So, it is your I3. So, I3 multiplied by the total resistance of the two parallel resistors R4, 5, 6 divided by R4. So, I3 is equal to 10.507 milliampere times R4, 5, 6. So, nasolve na natin kanina yung R4, 5, 6. That is equal to 3.5 kiloampere. So, 3.5 divided by R4 is 7K. So, I4 is equal to 5.24 milliampere. 5.254. Sorry, 254 milliampere. So, again, using KCL at node 2. Current entering is I3. Current leaving are I4 and I5. So, I3 is equal to I4 plus I5. 5, 6 pala. 5, 6. So, I5, 6 is equal to 10.507 milliampere minus 5.254 milliampere. So, that is equal to 5.253 milliampere. Okay. We can verify this one if we will simulate the circuit in electronic workbench. I simulated the circuit that we solved a while ago in electronic workbench to verify our answers. So, tama naman lahat. Nandito lahat yung branch currents. So, may mga discrepancies lang kasi syempre yung rounding of numbers. Okay? So, if you are not sure your solution, you can verify it. Let's try to solve this problem. So, we are going to solve R equivalent or the R total and the current in resistor R7. We will use source voltage or terminal voltage equal to maybe 12 volts. Okay? So earlier, I discussed already on how to redraw this kind of circuit. So, if we will redraw this circuit, what will be its equivalent circuit? So this is your R1, R2, R3, and since there is a resistor here, that will be your R4, then R5, and then this is your R6, R7, R9, R8, and R10. This is your R8 and R10. Ben na tem lang dagita. Is your source. So R1, R2, R3, R4, R5, R6, 7, 9, 8, and 10. Okay. Now we will label your current, direction of currents. So this is I1, I2, I3, I4, downward. Since there is no resistor here, so dito yung down direction ng current. I6, I9. This is, since R8 and R10 are in series, so this is I8, 10. And then, at the lower part of your circuit, so babalik na yung parent. So, the direction of your I7 will be like this. So, I7 and then I5. So, there is no resistor. This will be your I total, or it is equivalent or equal to your I1. Okay. So, from here, muna, R8 and R10 are in series. So, R810 is equal to R8 plus R10. Next, the combination of R8 and R10 is in parallel with R9. So, R9, 810 is equal to R9 plus R810. Next, after paralleling, so R8, 9, 10 is in series with R7. R7, 8, 9, 10 is equal to R7. Oh, sorry, this is parallel. This is parallel. So R7 in series with R8, 9, 10. Next, so in series and then in parallel again with R6. R6, 7, 8, 9, 10 is R6 in parallel with R7, 8, 9, and 10. Then R6 in series again with R5. So R5 plus R6, 7, 8, 9, and 10. Parallel R4. So R4 in parallel with R5, 6, 7, 8, 9, and 10. R3 is in series with R4, 5, 6, 7, 8, 9, 10. 8, 9. So R3 plus R4, 5, 6, 7, 8, 9, and 10. In parallel with R2 and in series with R1. So R2, 3, 4, 5, 6, 7, 8, 9, and 10. In parallel. So last one, our total in series with R1. 8, 9, and 10. So we will solve one by one. R8 and 10 10 plus 2, so that is 12. R9 is 6 in parallel with 12. That is 4. 7. So 8. 8 plus 4, 12. Then R6 is 6 in parallel with 12. 4 again. Then in series with R5, 4. So 4 plus 4 equal to 8. In parallel with R4, which is 8. So 8 in parallel with 8. 4. Then in series with R3, which is 4. So 4 plus 4 equal to 8. Then in parallel with R2, which is 8. 8 in parallel with 8 is 4. In series with R1, which is equal to 6. So your R total is equal to 10. 6 plus 4 is equal to 10 ohms. Okay. So we will now solve total current. So total current is equal to total voltage divided by total resistance. Total voltage is 12 divided by 10. That is 1.2 amperes. We are now going to solve I7. But before solving I7, we need to solve I1, 2, 3, 4, 5, 6. Okay? So we will solve now I2 because IT is equal to I1. But before solving I2, we will get all the combinations of R3 to R10, which is equal to 8 ohms. Why? Because we will use CDT in solving I2. So red draw our circuit. This is our R1, R2, and R3 to 10. So R1, this is our total current. R2, I2, and our I3 to 10. Salatan. R3, 4, 5, 6, 7, 8, 9, and 10. So in CDT, again, so CDT, I2 is equal to I total, which is the current supplying I2 and I3 to 10, multiplied by the total resistance. Total resistance is not equal to 10 because we will just consider the two parallel combination of the two resistors, which is the R2 and R3, 4, 5, 6, 7, 8, 9, 10. So this is equal to R2 plus R3, 4, 5, 6, 7, 8, 9, and 10 divided by your Rn, which is equal to R2. So R2 is equal to 8 ohms. So this is R2. IT is 1.2 times R2 plus R3, 4, 5, 6, 7, 8, 9, 10. They are in parallel, so it is not plus. Parallel dito eh. Sorry. So this is R2 in parallel. So dito ni R2 in parallel with R3, 4, 5, 6, 7, 8, 9, 10. So 4 divided by 8. Equal to 0.6 amperes. Next is I3. So go back to our circuit. We have here a node. Diba? Dito yun eh. So using KCL, I1 equal to I2 plus I3. So I3 is equal to I1 or IT minus I2. So I3 is equal to, by KCL, I3 is equal to IT minus I2. So 1.2 minus 0.6 equal to 0.6 amperes. Next, I4. So, I4, paano natin isosolve? Same procedure. We will reduce R5 to R10 into single resistor. So, again, we will redraw our circuit. This is R1, R2, R3, R4, and the combination of R5 to 10. This is R5, 6, 7, 8, 9, and 10. R1, R2, R3, and R4. The direction of I4 and the direction of I5 to 10. So solving for I4 by CDT. I4 is equal to, what is the current supplying I4 and I5 to 10? So it is your current I3. So I3 multiplied by the parallel combination of R4 and R5, 6, 7, 8, 9, 10. So R4 in parallel with R5, 6, 7, 8, 9, and 10 divided by R4. So I3 is 0.6 multiplied by this one, R3 in parallel with R4 in parallel with R5, 6, 7, 8, 9, 10. So, eto. R4 in parallel with 5, 6, 7, 8, 9, 10 is equal to 4 divided by R4, which is equal to, ano at value ni R4? 8 8 ohms. So divided by 8. This is I2. Box tayo pa lang lagi tayo answers. Currents. .3 amperes. So, solving for I5, this one. Since we already solved the I2, I4, and total current, using KCL at this node, this one. So, diba, this is our total current. Current entering is equal to current leaving. So, itulatan, batognan. So, KCL entering to the node is I2, I2, I4, and I5. So, positive. I2 plus I4 plus I5 minus IT is equal to 0. So, solving for I5, we have IT minus I2 minus I4. So, IT is 1.2 minus I2 is 0.6 minus 0.3. So, recheck natin nasan yung I2. So, I2 is 0.6 and I4 is 0.3. So, that is equal to 1.2 minus 0.9 is 0.3. 0.3 amperes. Next branch current that we are going to solve is the I6. So, eto yung tricky dito. Kasi ano yung current na mag-flow dito kahit walang resistor? Ito. So, KCL, let's say this is the node. And we will name this current as IA. Diba? Since may I5, I6 na tayo, so we will name it as IA. Then, we will have a KCL here para makuha natin yung IA. So, etong IA, siya ang magsusupply sa branch current I6, R6. Okay? Kung hanggang I7 lang kasi tayo, so, if you want to solve I9 to 10, 8, 9, 10, kukunin mo na naman yung current dito, IB. Then, this IB will supply branch currents R8, 9, 10. So, since hanggang R7 lang tayo, so dito lang tayo sa IA. So, IA is equal to I3 minus I4. So, we will have a KCL here. So, dito na lang sa taas. So, I A is equal to I3 minus I4. Our I3 is 0.6 and our I4 a while ago is 0.3. So, IA is equal to 0.3 amperes. Solving for I6, again using CDT. Let's redraw. So, ito yung R6 natin. And this one is the combination of R7, 8, 9, and 10. So, this current is our IA. Solving now for this I6 is equal to IA multiplied by the parallel combination of R6, 7, 8, 9, 10. 7, 8, 9, 10 divided by R6. So, IA is 0.3. R6, 7, 8, 9, 10 na solve na natin, which is equal to 6, 7, 8, 9, 10 equal to 4. Divided by R6 is 6 ohms. So, that is equal to 0.2 amperes. Last one, I7. Ito. So, mag-KCL na naman tayo dito sa point na to, sa node na to. So, may I5 na tayo, may I6. So, we can solve easily I7, KCL. I7 plus I6 minus I5 is equal to 0. So, I7 is equal to I5 minus I6. So, I5 natin, 0.3 amperes minus 0.2. So, I7 is equal to 0.1 ampere or 100 milliamperes. So, let's check this one in electronic workbench kung tama yung solution natin. So, eto na yung circuit natin kanina. Ito yung unknown, I7, I1, I2, hindi ko na nalagyan ng ammeter, I3, I4, I5, I6, I7. So, our I7 must be 100 milliampere. Let's see. So, 100 milliampere. So, tama naman lahat yung nakuha nating currents. Hindi na natin sinolve to kaya hindi ko na nilagyan ng ammeter. So, that's it. I will give activities again regarding series parallel combination. And I will give also exam regarding this topic. For your laboratory, I will be the one giving the circuit diagram, and then kayo yung maglalagay ng mga values. So, dapat walang magkakaparehong values na gagamitin. So, all of you must be unique. Okay? Kung may magkapareho man, so, divided by 2. Kung tatlo kayong magkakapareho, divided by 3. So, wait for your laboratory experiments. I will post it soon. Okay? Thank you and good day.